Welcome to the Copperfield Electric Podcast. If you want to fix a failing heart today, a surgeon doesn't just, crack your chest open anymore.
Right, they go in through a tiny hidden artery.
Exactly. And today we're taking a deep dive into how modern electricians do, well, the exact same thing to your house. We're tackling one of the most honestly paralyzing fears of homeownership.
Oh, the dreaded whole house rewire.
Yes.
I mean, most people picture a crew showing up, draping all that plastic sheeting over the furniture, and basically taking a wrecking ball to the living room.
Oh, totally. You just imagine breathing in drywall dust for 6 weeks.
Yeah, and writing a second massive check just to rebuild the walls you destroyed.
Right. And honestly, that fear alone keeps so many of you living with these outdated, potentially unsafe electrical systems. You ask yourselves, can I upgrade my electrical wiring without tearing walls?
Just a totally fair question.
It is, and that's our mission today. Our research comes directly from the experts at Copperfield Electric. They're a family-owned, fully licensed, and background-checked outfit.
Right, serving Southern California's Orange County.
Exactly. So we're talking about communities like Irvine, Anaheim, Santa Ana, Costa Mesa, and Newport Beach. And their field notes provide this amazing masterclass in how upgrading your home's nervous system, so to speak, is no longer a demolition job.
Yeah, it's really not. The physical reality of modern electrical work is, well, it's much closer to that minimally invasive surgery you mentioned.
Right.
Electricians rely on, spatial awareness, specialized tools, and just a really deep understanding of structural anatomy to bypass the finished walls entirely.
Okay, so let's get right into the mechanics of that invisible surgery. Because if you aren't tearing down the drywall to lay a new cable, you need a way to navigate that dark, insulated void inside those walls.
Yeah, you do.
And the core tool here is something the sources call a fish tape.
Oh, yeah. It is the absolute workhorse of the industry. And despite the name, it actually has nothing to do with adhesive tape.
Wait, really?
Yeah.
Yep.
No. A fish tape is this long, semi-rigid coil. It's usually made of tempered spring steel or sometimes fiberglass.
Okay.
So when an electrician needs to run a wire from, let's say, your ceiling down to a new outlet near the baseboard, they don't open the wall.
Right.
They drill a highly targeted tiny hole at the top plate of the framing and another tiny hole at the bottom.
Just tiny access points.
Exactly. And then they feed the fish tape down from the top, basically blindly navigating through the wall cavity. They're just feeling for obstructions until they can grab it at the bottom hole.
Wow. So they're essentially threading a needle in the dark.
Pretty much.
And once that steel tape emerges at the bottom, they just, firmly attach the fresh copper wire to it?
Yep, they attach it and just pull the whole assembly back up to the wall.
That's crazy.
I know. And the best part is, the only visible cuts are the ones that end up completely hidden behind the new plastic outlet cover anyway.
That is exactly like the laparoscopic surgery analogy, just making tiny incisions to fix major internal issues.
Exactly. And, the choice of material for that tape is super critical.
Yeah, really? How so?
Well, steel is great for pushing through really dense fiberglass insulation, right?
Mm-hmm.
But if the electrician is working anywhere near live existing circuits,
Oh, because it's metal.
right, they will switch to a fiberglass fish tape because it doesn't conduct electricity.
That makes sense.
Yeah, it's a very calculated sensory process. They are literally feeling the friction and the structural layout of your home just through the tension in the tape.
Which means the architecture itself, totally dictates the strategy.
Absolutely.
If an electrician is working in one of those classic single-story California ranch homes, the kind you see constantly around Tustin or Newport Beach, they have a massive structural advantage hiding right above the ceiling, right?
The attic.
The attic.
Yeah, attic routing is the absolute preferred method for any single-story home with a pitched roof.
Because it's just open space.
Exactly. Those homes usually have a sprawling, unfinished space directly above the living areas. So rather than trying to drill horizontally through, a dozen wall studs to get a wire from the kitchen to the living room,
Which would be a nightmare.
total nightmare. Instead, the electrician just takes the path of least resistance.
They just go straight up.
Exactly. They take the wire into the attic, run it across the entire length of the house just by walking along the ceiling joists, and then they drop it directly down into the specific isolated wall cavity where that new switch is going.
So it basically isolates the disruption.
Completely. The new wiring bypasses the finished living space entirely, right up until the final few inches.
Wow.
Yeah, the electrician will map out the layout from above, drill down through the horizontal wood framing holding up your ceiling, and just drop a weighted string or chain down the inside of the wall.
Oh, a weighted string. That's clever.
Yeah.
Yeah.
And then they use a magnetic tool or a hooked fish tape to pull it out through the little outlet hole.
Okay, so that makes perfect sense for adding a brand new circuit. But the sources also highlight situations where you just need to replace an existing dead wire.
Right. Yeah.
And there's this technique mentioned called the pull-through trick.
Ah, yes, the pull-through.
Yeah, where you tape the brand new wire to the old wire and simply use the old wire to drag the new one into place as you yank it out of the wall.
Basically using the existing infrastructure to install the new infrastructure.
Yeah.
It's a brilliant shortcut when the conditions actually allow for it.
See, I have to push back on the reliability of that, though.
Okay, why?
Because, I mean, I can't even pull a loose drawstring back through the hood of my sweatshirt without it, like, bunching up, binding, and getting permanently stuck.
This is a hilariously accurate analogy.
Right, so how do you pull a stiff, heavy-gauge electrical cable through a wall cavity that has been sealed up and settling for 30 years?
Well, your sweatshirt analogy highlights the exact physical limitation of the technique. The pull-through trick is highly situational.
Okay, so it doesn't always work.
Definitely not. It only works if the original path is perfectly straight and loose.
Ah.
Yeah, if the original electrician wove that old wire tightly around plumbing pipes, or if it takes a sharp 90-degree bend through a corner stud, you absolutely cannot pull it.
Because pulling it just, wedges it tighter against the wood?
Exactly. Or worse, the tape binding the two wires snaps from the tension.
Oh, no.
Yeah, if that happens, the old wire comes out, the new wire falls down inside the wall cavity, and you have entirely lost your routing path.
And suddenly you're doing exactly what you tried to avoid. You have to start cutting drywall to find it.
Precisely. Which is why an experienced electrician will always test the tension on the old wire before committing to it.
They give it a little tug.
Right. If they feel mechanical resistance, they abandon the pull-through immediately and switch back to fishing a new path.
It's all about risk mitigation.
Totally.
Now, speaking of mitigation, what about areas where you actually don't mind seeing the mechanical components, like utility spaces? We're talking garages, dedicated laundry rooms, unfinished basements.
Sure.
The sources bring up surface-mounted conduit for these areas.
Yes, surface conduit. That's the PVC or metal piping that runs directly on the outside of the finished drywall.
So the wires are just housed safely inside the pipe.
Exactly. And from a labor perspective, I mean, it requires absolutely zero cutting into the walls, which makes it incredibly fast.
But there's a much deeper safety application for this, specifically regarding older architecture, right? The sources single out homes built before 1980 in Orange County.
Yeah, this touches on a really serious historical evolution of building materials.
Right.
If a home was built prior to the 1980s, there is a distinct possibility that the existing electrical insulation, or even just a drywall joint compound around it, contains asbestos.
Wow. Okay.
Now, asbestos is relatively harmless if it remains completely undisturbed inside the wall cavity.
But the moment you start yanking on those old wires to drag them out.
Exactly. You are grinding them against the drywall and aerosolizing microscopic carcinogenic fibers right into your living space.
Which turns a standard electrical upgrade into a literal hazardous material crisis.
It really does. So in those specific scenarios, surface-mounted conduit acts as a quarantine strategy.
Oh, that makes so much sense.
Yeah. The most responsible approach is to leave the hazardous, outdated wiring entombed inside the walls where it can't hurt anyone.
You just completely disconnect it from the power source.
Right. Make it dead.
Yeah.
And then you run the brand new, modern wiring inside surface conduits right over the top of the wall.
So you solve the electrical capacity issue without ever triggering a respiratory hazard.
Exactly. It's a lifesaver.
That is a brilliant workaround. You're just adapting the solution to the environmental reality of the house.
Yeah, you have to.
But, up to this point, we've painted a highly optimistic picture.
We have.
Laparoscopic fishing, attic highways, quarantine conduits. But we really need to look at the other side of the coin.
The unavoidable roadblocks.
Exactly, because listeners are inevitably wondering, if all these low-impact tricks exist, why do electricians ever resort to actually cutting the drywall?
Well, the honest truth is that sometimes the drywall knife just has to come out.
Yeah.
There are physical, structural realities inside your walls that simply cannot be bypassed or finessed with a fish tape.
Okay, like what?
The most common modern culprit is something called fire blocking.
Wait, fire blocking? Because earlier you said they just drop a wire down a vertical stud bay from the attic. But modern walls aren't just empty vertical tubes, are they? Like, don't they have structural braces?
They do, and it stems from a critical shift in California building codes, um, particularly for homes built or heavily renovated after 1990.
Okay.
To understand the necessity of fire blocking, you kind of have to look at the physics of a house fire.
Okay, paint a picture for me.
So imagine the empty vertical space between two wooden wall studs as a chimney.
Right, because heat rises.
Exactly.
Yeah.
So if an electrical short sparks a fire down at an outlet near the baseboard, that hollow vertical space allows the flames to draw oxygen from below and draft rapidly straight up into the attic.
Wow, it acts like a literal flue.
It does. It accelerates the burn rate exponentially.
Yikes.
So to combat this chimney effect, modern building codes mandate fire blocks.
What are those exactly?
Builders must install horizontal pieces of 2x4 wood midway up the wall cavity. They basically bridge the gap horizontally between the vertical studs.
Ah, so it effectively cuts off the oxygen draft and stops a fire from traveling vertically inside the wall.
Precisely. It's brilliant for fire safety.
But if the electrician is feeding a fish tape down from the ceiling,
Yep.
halfway down the wall, they just hit a solid block of wood.
Bam. The invisible surgery is effectively over.
Oh, man. So you have no choice but to break the drywall to drill through that structural block.
You hit the nail on the head. The electrician must cut an access hole in the drywall precisely where that horizontal wood block is located.
Okay.
They drill a vertical hole through the wood block itself, feed the new wire through, and then they can continue fishing it down to the outlet.
That irony there is incredible.
Oh, it really is.
The very building codes explicitly designed to make modern homes vastly safer from fire actually make upgrading those homes significantly more difficult and inherently more destructive to the drywall.
It is the ultimate double-edged sword of modern construction.
Wow.
But, modern fire blocks aren't the only structural roadblock.
Oh, there's more.
Oh, yeah. If you own a truly historic property, say like a Craftsman, built before 1940, you are likely facing the grandfather of all electrical headaches.
Let me guess. Knob and tube wiring.
You got it. Knob and tube.
You see that term constantly in real estate disclosures. Just the name sounds like something from the Industrial Revolution.
It basically is.
Why was it built that way in the first place?
Well, the design was entirely based on heat dissipation.
Okay.
Instead of bundling the hot, neutral, and ground wires tightly together inside a single plastic sheath like we do today, early electricians ran the individual wires completely separate from one another, usually several inches apart.
Really? Why?
Because the air inside the wall cavity acted as the primary heat dissipator to prevent arcsing in fires.
Oh, wow. And to keep them separated, they stretched them tight and anchored them to the wooden framing, right? Using those little ceramic knobs.
Exactly. And where the wire had to pass through a wood stud, they protected it with a little porcelain tube.
Hence knob and tube.
Bingo. But here's the problem for us today. Because the wires are physically stapled, anchored, and threaded through porcelain inside the sealed wall, that pull-through trick we discussed earlier.
It's a physical impossibility.
Completely impossible. Furthermore, the insulation on wiring from the 1920s and 30s was made of cloth and rubber.
Oh, no.
Yeah. And over a century, that rubber basically bakes in the heat of the wall and becomes incredibly brittle.
So trying to pull that out would be like trying to pull a dry, cooked spaghetti noodle out of a tight bundle.
Perfect analogy. It's just going to shatter and snap instantly.
That sounds like a nightmare.
It is exactly the problem. Because it crumbles when touched, and because it's woven through the very skeleton of the house, removing and replacing knob and tube wiring requires drastically more access points.
So you're cutting a lot of holes.
You have to. The electrician simply has to open up more sections of the wall to safely extract that fragile old system and securely route the new copper.
And, regardless of whether you have modern fire blocks or ancient knob and tube, every single one of these newly fished wires eventually has to make its way back to the heart of the system.
Right, the electrical panel.
Exactly.
Every single circuit in the home converges at that central breaker box.
And if your panel is mounted on the outside of the house or in an unfinished garage, running those dozens of new wires into it is a relatively clean process, right?
It is. It's usually pretty straightforward.
But what if your panel is located on a finished interior hallway wall?
Well, then the drywall immediately surrounding that panel is going to take a hit.
It has to.
Yeah, you simply can't cleanly 20 new thick cables into a single metal box without opening the wall up to manage the traffic jam.
Which brings up a critical point of logistics for anyone listening.
What's that?
If you are already committing to opening up walls and running new high-capacity copper wire throughout the house, it is the absolute ideal time to bundle a full panel upgrade.
Oh, 100%.
Especially considering the massive continuous loads modern homes are drawing now. I mean, we are in Southern California. EV adoption is ubiquitous.
Right, everyone has one.
You aren't just plugging in a refrigerator anymore. You are plugging in a massive vehicle battery that draws high amperage for, like, 8 hours straight.
Exactly. And the sources from Copperfield Electric highlight that they actually specialize in panel upgrades for EV charging.
That's perfect timing then.
It is. Doing the panel upgrade simultaneously with the rewiring prevents you from enduring the disruption twice. It ensures the heart of your system is actually strong enough to pump electricity through those newly installed arteries.
Right. Okay, let's transition from the mechanics to the practical reality.
Okay.
Let's say you're listening and you're ready to pull the trigger on a project like this. What is the actual step-by-step roadmap when you book the service? And, of course, the question everyone is waiting for, what is the final bill going to look like?
The roadmap begins with an intensive pre-surgical inspection.
Not just showing up with a drill.
Definitely not. A reputable electrician does not show up on day one with a drill. They spend hours mapping the house.
What are they looking for?
They trace the existing circuits, locate the panel, visually inspect the attic clearance, and strategize the routing approach for every single wire. They're specifically hunting for those hidden fire blocks before they make a single cut.
That makes sense.
Yeah. Then once the mapping is done, the actual cutting begins.
But let's manage expectations here. When we talk about cutting drywall for new outlets, we are talking about incredibly precise dimensions.
Very small.
Right. The standard cut for a new wall switch or outlet is roughly 3.5 inches tall by 2 inches wide.
It is barely larger than a deck of cards.
And if they do hit a fire block...
The access hole is usually just the size of a fist. It's really not that bad.
Okay, so following the routing and the installation of the new devices, you hit the fourth step of the roadmap, which involves a crucial handoff.
Ah, yes. Patching and permits.
Right, and this is where so many homeowners get caught off guard, because electricians are highly specialized masters of voltage, load calculation, and safety codes.
We are.
They're not drywall finishers.
No, we are definitely not.
Yeah.
In the vast majority of cases, the electrician's scope of work stops the exact moment the electrical system is safely installed, energized, and tested.
So they leave holes in your walls.
Well, they will secure the wiring, absolutely, but they do not pull out a bucket of joint compound to patch the holes.
You generally need to hire a dedicated drywall professional for the patching.
Exactly. And the good news is, a skilled drywall pro can make a fist-size access hole or a 3.5-inch outlet cutout completely disappear.
Like it was never there.
Right. Once it's painted, it is invisible. And then finally, a city inspector comes out to verify the code compliance and legally close out the permit.
Okay, so that is the physical reality of the project, but let's address the financial reality.
The big question.
Yeah. The sources provide specific data for the Orange County market. To completely rewire a standard 2,000 square foot home, the cost generally falls between $14,000 and $20,000.
Yep.
Now that is a massive $6,000 variance. Break down the math behind that sliding scale.
Well, the variance is entirely dictated by labor time and structural accessibility.
Okay.
If you own a modern single-story home with a sprawling roof that offers unobstructed attic access for routing, the labor is highly efficient.
So you're at the lower end.
Exactly. You will likely sit at the $14,000 end of the spectrum.
But if you live in a pre-1940 two-story Craftsman packed with stapled knob and tube wiring,
Oh, yeah.
or a post-1990 home riddled with horizontal fire blocks where the fish tape just keeps hitting dead ends,
Your labor hours just skyrocket. The electrician has to make more physical wall cuts, drill through more structural lumber, and spend vastly more time navigating obstacles.
and time is money.
Exactly. That lack of accessibility pushes the project toward the $20,000 mark.
Which, I mean, that is a substantial capital investment in your property.
It really is.
And this is exactly why the sources from Copperfield emphasize the importance of diagnostic integrity.
Yes, that initial mapping phase.
Right, because that phase is where a dishonest contractor can easily inflate a $14,000 job into a $20,000 job just by claiming structural roadblocks that don't actually exist.
It happens more often than you'd think.
So you need an electrician who builds their value proposition on honest troubleshooting.
Exactly. Rigorous troubleshooting prevents unnecessary upselling. A true professional will only diagnose and charge for a problem if it demonstrably exists, saving you significant capital in the long run.
And, the reality of home ownership is that electrical failures don't happen on a convenient schedule. If your main breaker starts tripping or a circuit starts audibly arcing behind the wall at midnight on a holiday, you need a contractor who treats that as a structural emergency.
Right. And Copperfield specifically offers 247 emergency support for that exact reason.
That's huge peace of mind. Furthermore, to help you figure out where your specific architecture falls on that $14,000 to $20,000 spectrum, they offer free on-site estimates.
That's great.
Yeah, they map the attic, identify the fire blocks, and provide a firm diagnostic number backed by a 100% satisfaction guarantee.
And honestly, establishing a firm diagnostic number before the first hole is ever drilled is the ultimate form of risk mitigation for the homeowner.
Absolutely. So to summarize our deep dive today, upgrading your home's infrastructure to handle modern technological demands, whether that's induction ranges, smart home arrays, or high amperage EV chargers, it does not require gutting your house to the studs.
No, it doesn't.
Through surgical wire fishing, strategic attic routing, and a deep understanding of building codes, modern electricians can revitalize your home's power grid with surprisingly minimal disruption.
It really replaces brute force with architectural strategy.
It does.
But, looking at how complex and expensive it is to navigate current building codes like fire blocking, it raises a really fascinating question about the future of residential construction.
Ooh, okay. Where are you going with this?
Well, our homes are rapidly evolving into massive technological hubs.
True. The electrical loads are only getting heavier.
Right. And the wires buried deep inside our walls are quickly becoming the primary bottleneck for integrating new technology.
So what's the solution?
Well, think about it. If traditional wood framing and sealed drywall make current homes so financially punishing to upgrade, how long until the architecture industry fundamentally changes the blueprint?
Okay.
How long until we stop burying wires in inaccessible cavities and start building homes with modular, easily accessible wiring highways built directly into the baseboards or crown molding by default?
Oh, wow. Imagine a living room where the baseboards simply snap off on a hinge, revealing a hollow, dedicated conduit. You could just drop a new high-voltage cable in, snap the baseboard shut, and fully upgrade a room in 10 minutes without a single fish tape or drywall saw.
Exactly. That would completely revolutionize the life cycle of a house.
It really would.
It is the inevitable next step, I think, making the physical shell of our homes as adaptable and easily upgradable as the smart technology we place inside them.
That is a fascinating thought to leave on. But until those modular baseboards become the industry standard, at least we know the professionals have the tools to navigate the walls we currently have.
They absolutely do.
Thank you so much for joining us on this deep dive. Hopefully the next time you look at the blank drywall in your living room, you'll see it a little differently. You'll know that if you ever need more power, there isn't a wrecking ball waiting for you, just a highly calculated, invisible surgery.